Welcome back to the classroom, Mr. Wong here. Today we'll be covering the Module 6 Inquiry Question 1, the 2019 Physics paper, Question 29. We have a particle with a mass of m, a charge of q, accelerated from rest, meaning by initial velocity is 0, through a potential difference of v. Assume that the only force acting on the particle is due to our electric field. So E here, that's associated with the potential difference. Show that the final velocity of the particle can be given as this value here. Okay, so there's a couple of things we can unpack. Firstly, the concept that we have a charge that's being accelerated means there must be a force associated to it. Okay, so we have a charge that has a velocity of 0, and then we manage to move it to a particular velocity that we don't know the value of. Okay, what that means is we must have done some work to make the object move. Now work is the amount of or work is defined as the charge times potential difference. So how much work you've done is how much work you've done to move a charge from one position to another. Okay, we also know that work done is also considered the change in kinetic energy. So if I have a look, the change in kinetic energy, that formula is equal to half mv change in v squared. That's what we're looking at here, and that's equal to qv. Now if we think about it, change in v squared, so change in v is final minus initial velocity. But we know because u is 0, the change in v will end up being the same value as the final velocity. Okay, so we can just end up writing this equation as half mv squared equals to qv. From there, we can find that if we rearrange everything over, so v squared equals to qv divided by m times 2 up here. So v squared is therefore 2qv divided by m. And that's how you do the question, or how you respond to this question here. If you found this video useful in deriving the equation and giving the explanation, give it a like for support and see other videos come out soon enough. Thank you for watching.